Let's see this problem, product of array except self. So this problem says that given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. Means we have to multiply all of these elements except the number which we currently are present at. Okay, suppose we are at 0th index, then we do not have to multiply 0. We have to multiply all of the rest of the elements. Okay, that's how we will calculate nums 0. Okay, and similarly we have to calculate the rest of the uh, numbers of the resultant array. And it says that the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer, and you must write an algorithm that runs in big O of n time without using the division operation. We don't have to use the divide. We can just uh, take the multiplication of all of those numbers in input array, and then we can divide it by the number which we currently are on. Okay, and also we have to run it in big of n times. So it means that we have to loop through the input array only once, and we cannot write any loop inside that. So this is the input array 1 2 3 4, and this is the output. So the 24 is calculated by multiplying 2 3 and 4. We have not multiplied 1. 12 is calculated by multiplying 1 3 and 4. We have not multiplied 2 here. And 3 is calculated, sorry, the 8 is calculated by multiplying 2 2 1 and 4. So this is 8. And the 6 is calculated by multiplying 3 2 and 1, that is 6. So we have to omit the position which we are currently calculating inside the input array. Okay, so let's see how can we solve this problem. So let's see this example. This is our input array and this is our output array. So how do we calculate this 24? Is that we multiply all of these elements except the element at index 0. Similarly for the index 1. So how do we calculate 12? We multiply all of these numbers except the number which is present at index 1. Same for the 8. We multiply all of these numbers except the number which is present at index 2. And same for 6 and 24. So if we see that we are following a pattern, that we are multiplying the numbers at the left and the right side of the numbers which we want to calculate. Suppose we want to calculate this 8, so we'll multiply all of these elements at the right side, left side of the 3, and the elements at the right side of the 3. So this problem we can divide it further it into two sub problems, that we have to calculate the multiplication of the elements on the left side and the multiplication of the elements on the right side. So let's first solve the problem of the elements on the left side. So let's say we are on the first index. So what we can do is we can keep a track of the multiplication of the elements with a variable. Let's say we take the variable, and when we are at 1, so the multiplication of the element at the left side will consider it as a 1, as we'll have to multiply that multiplication with the multiplication on the right side. So we'll take it as a 1. And when we'll go from index 1 to index 2, we will multiply this multiplication with the number on the left. So it will be 1 multiplied by 1, so it will be 2. Sorry, it will be 1. So 1 multiplied by 1, it will be 1. So for 2, the multiplication on the left side will be 1. And when we move forward at 3, we will take the multiplication on the left side and multiply this to with this multiplication, and we will calculate it. So it will become 2. So the multiplication for the index 3, on the left side will be 2, and when we go to the element 4, we will calculate it by, this is the total multiplication, so 2 multiplied by 3, so it will become 6. So the total multiplication for index 4 will be 6, and for 1 it will be 6 multiplied by 4, it will become 24. So this is how we will get our multiplication, our left multiplication at each index. Okay, so this solves our one problem. Now let's see the another subproblem that we want the multiplication of the right side. So let's say we are at index 0 and we want to calculate the multiplication of the right side. So one thing we can do is that we can run a loop from index 1 to the end of the index and get the multiplication of the right side, and we can do it for the all of these elements. But the problem is that we will be running loop inside loop, so we will not have the big O of n complexity, time complexity. So what we can do is we can we can follow the same approach as we have followed for the left multiplication, but instead of storing this result inside a variable, what we'll do is we'll store it inside a array. So we'll start from the right side and we will store it in the array. So for the last index, we will consider the right side multiplication as 1, and as we move forward we will multiply this 2 and we'll store its result as 1. So for 4 the multiplication on the right side will be 1, and we'll move forward. So for 3 the multiplication will be 4 into 1, it will be 4. Similarly we'll move forward. For 2 it will be 3 into 4, so it will be 12. Similarly for this one, 2 into 12 it will be 24. Okay, so this is how we'll get our right side multiplication, but we'll store it in array. So once we get the left side and right side multiplication, we can easily find the resultant array by multiplying the left multiplication and the right multiplication for a given index. So let's see the code based on this approach. So this is the input array we have given, and this is the diagram I have created. This is our input array and this is our output array, and this is the multiplication of the right side of this element. So for 4 it is 1, and for 3 it is 4 multiplied by 1, it is 4. So for this 2 it is 3 multiplied by 4, it is 12, and for 1 it is 2 multiplied by 12, it is 24. So we'll create our right side multiplication array based on this. So let's create that first. So we'll create an array and we'll start it from the end of this input array. So for the last element, multiplication of the right side will be 1. So we'll say that here, if I is equal to nums dot size minus 1, then we'll say that right side multiplication here is 1. Otherwise, let's say we are here at 3. So the right side multiplication of this 3 will be multiplication of 4 into the rest of the multiplication. So we'll do that here. So that will be nums I plus 1, and which we will be multiplying with the rest of the multiplication which we have now. So that will be right side of I plus 1. Okay, so that will give us the multiplication of our current element, multiplication for our current element, and this is how we'll calculate the right array. Let's calculate the left array and our result. So let's create a variable for holding our left side multiplications and array. So this will loop it from 0 to the end of the array, and let's calculate the answer now. We'll multiply the left elements with the right side element. After multiplying the left and right, we'll get our answer. And after this answer is calculated, we'll update our left side multiplication as left is equal to left into the current element. Okay. So this our left side multiplication will be updated after we have calculated our current element. Okay. And after that we'll return our result.